Good afternoon, everyone. My name's Steve Marsh. I'm the founder of Geospoc. I'm here today to talk to you about how we are helping to create digital blueprints of the planet. But first, I want to talk about global trends, specifically human trends. We have rising population levels across the globe, an over-urbanization of that population, which is leading to increased demand on our own physical infrastructure. And so, for the first time ever, we're starting to see that physical infrastructure crack under increasing demand, and that's leading to issues across every city you can imagine with congestion and pollution. Now, actually, on the technology side, we have a glimmer of hope. We are actually seeing the digitization of that infrastructure from everything from cities to shipping, to mobile IoT, to automotive, even data technology, from the things that we wear and walk around with. In fact, we have so much data that vast areas are growing. And the three big areas that we see, most machine-to-machine data, is indeed smart cities, which is great news, mobility and logistics, and IoT and mobile networks. Now, I'd like to plant an idea with you, which is the idea of a mobile sensor platform. I'm going to choose the example of a vehicle here. We've heard an awful lot about autonomous vehicles, but the vehicles we have today are actually connected. They're very sophisticated sensor environments themselves. They can pull in information about that environment through LiDAR, radar, but also simplistic things like, are we braking, are we accelerating? Is the windscreen wipers on? Can we understand how that environment is actually functioning? Now, I was talking at an automotive conference a couple of weeks ago, and they were very much focused on the primary use cases of mobility data. It's, can we offer mobility as a service? Can we have predictive maintenance? Can we make our customers happier? But actually, the secondary use cases of that data are far more interesting when we put them into a global context. We can actually pull out traffic conditions of every city on the planet that has connected vehicles. We can understand how air quality functions in urban environments. We can understand microclimate. We can understand road safety. We can build intelligent urban ecosystems by repurposing this data that was designed for something completely different. In fact, we mentioned about building digital blueprints, and the question that I want to put forward to you is, do you think we can actually help solve planet-scale problems with these digital blueprints? Can we take in automotive data? Can we understand maritime for global shipments? Mobile data for movements of people? Can we understand how cities are actually being used by their citizens and how to optimize those urban environments? We are customers of the environments that we live in. Can we make it better? Now, the trouble with digitization of everything, and if you'd like to step outside after the talk and talk to ARM, they will tell you about the insane amounts of data that's being generated by connected devices. Gartner are predicting that by 2022, we're going to have 54 exabytes of IoT data being generated on an annual basis. That's more than we are currently projected to manufacture in terms of storage capacity. It's more data than has ever been produced in the history of humankind. We've also got big issues with 1 trillion connected devices by 2035. This data is only ever going to get bigger, it's going to get faster, and we're going to ask ever more from it. So the vast majority of that value that is being generated by new data is being hindered by current database technology. It simply wasn't designed for the scale of future and for building intelligent urban ecosystems. Now, that's actually where we come in. Geospoc was started 7 years ago. We're a company headquartered in Cambridge in the UK, and actually that's where our technology originates from. The technology that underpins our solution was originally designed to do real-time simulation of human brain function, taking a brain's 100 billion neurons and 100 trillion synapses and trying to recompute them all in a single millisecond. That type of extreme scale thinking, extreme parallel thinking, extreme data led to our understanding that actually the same techniques used in brain simulation and supercomputer research can be utilized to help us solve some of these planetary issues that we solve. Now, actually, there's a gap. There's a gap in all current database technologies. We have many different categories. Some of them originate in the 1970s. We had a next generation of big data in the early 2000s, and then in-memory data processing systems over the past decade. But really, no one has a spatial big data engine that can deal with exabytes of machine-to-machine generated data, have it immediately gather those insights to power next-generation applications. And a big goal of our company is to unify these 4 lifetimes of data. Everything from what's happening right this second to what's happened recently to history. Now, we want to do this so that we can make decisions on the fly and on demand. Traditional big data systems can take weeks to process an insight, by which time that physical scenario has moved on, never to repeat itself. Let's take the example of urban congestion. If we want to help solve urban congestion, we need real-time insights to where all of the vehicles are right now. But also we need recent data. Where were they over the past 10 minutes? Where is congestion starting to form? And now we need to ask the question, which is this normal behavior? Does this historically compare to this time of day, day of week, season of year, weather condition? And we need to answer those questions on the fly so we can intervene and optimize those physical world outcomes. Now, we do this for our spatial big data platform. I won't dwell too much about this, but a key part of what we want to do is be able to manage the complex data that comes from urban environments, from many different data sources, allow you to explore petabyte scale and up data sets, and then open that city environment to be an innovation platform, to be able to power your existing business intelligence, your existing data dashboards, new AI, machine learning, citizen services. Now, we do that by being able to abstract away the sense component of an environment from the act component. And through this way, we can actually give contextual intelligence and bridge this gap. So no longer are we stuck into a single silo, one application, one analytics, one database, one sensor. It can take you many years to develop those applications, whereas we already have sensors in the environment. I'm carrying one in my pocket right now. You drove in one here today. There's ships delivering your goods that have sensors on them. The data is already there, but if we can repurpose it and allow every innovator, every company, every academic, every government official to come in, understand how that data works and operates, we can enable data-driven decision-making and optimize those physical world outcomes. Now let's talk about the digitization of city infrastructure. This is the hope that I have, that we can digitize our environments that we live in fast enough to solve the problems, the human problems that we experience on a day-to-day basis. Now I'm going to take Cambridge data. It's where our headquarters are. We run the Cambridge Smart City Data Platform. They have 86 different types of sensor in that environment. They have smart street lights, smart traffic lights, microclimate sensors, pollution monitors, ANPR cameras, Bluetooth, flow control, smart parking meters. They even have smart rubbish bins. But all of these different data sets were completely siloed. You could never get complete contextual intelligence. In fact, you ended up with this scenario, where it would take years to develop a new sensor, to get it into the environment, pull out analytics for one insight. And we decided actually that was the wrong approach. We went in, and through our technology, we were able to bring everything into our spatial big data platform and open up that interface for innovation. This is allowing people to bring their own ideas and take the insights out of the data themselves. And this has allowed us to build what we call our intelligent city platform. Plug in and play in with all of your data as you get new sensors in the environment into a centralized data hub. And you can turn cities into innovation platforms. They can be the app stores of the future. You can allow third-party collaborators to come in and help you optimize that environment, help solve those problems, whether it's bringing out a new citizen service, a new mobility service, a new delivery engine. That can be opened up, but then we can also bring out the insights and analytics to allow city managers to pull the right levers to optimize that environment on the fly as needed. So in Cambridge, we took in pollution data. We were able to do air quality prediction. We're able to understand traffic delivery points. We're able to map those flows as they move through the environment. We know that delivery vehicles cause congestion, especially in rush hour. So this is allowing the city to make intelligent policy decisions to change what vehicles are allowed on what roads and at what times of day. In terms of traffic systems, again, we can work with third-party providers. And this is an ANPR number plate recognition provider. They have street cameras. They're able to apply AI models to do detection of those number plates. We're able to then move forward and map those vehicles as they move through a junction. This is allowing you to extract away from the raw image data, vehicle movement data, and utilization of our physical road network. Again, bringing all of the sensor data in, contextualizing it, and then allowing you to act upon that context in a real-time basis. We can move towards dynamic, demand-driven traffic systems rather than static timer-based. This allows traffic to keep moving, keep congestion down. And as we know, congestion is directly linked to the amount of pollution in a city. So free-flow traffic is a big goal. Now, as we start seeing congestion form in a city, we can build out AI models on the fly, on demand, to help us predict what the next 10 or 15 minutes of traffic system is going to look like. It allows us to interact with that situation and choose the best outcome we want. Test it virtually, deploy it physically. Now, of course, we have to talk about Singapore and Singapore's fantastic Smart Nation platform. The depth of thinking and breadth of thinking in this place is quite frankly astounding. And with the Smart Nation platform and the open data, you can actually bring all of this into one place. And in fact, that's what we did. We ingested everything from traffic incidents to taxi availability to weather data to pollution, even which way the wind blows. That's quite important. We're able to bring in the camera data that the LTA have very kindly provided. And so what we're able to do is nationwide congestion maps that can be updated on the fly, which can be correlated with weather conditions, with pollution incidents. And this is allowing us to start making those insights from the environment, being able to make intelligent decisions. Now, of course, Singapore is also a great shipping nation. So it's nice to talk about the maritime emissions. Now, we have land-based emissions in terms of automotive, but ships are also a very big polluter in the environment. And if we want to tackle global problems, we need to look at global data sources. Now, maritime is quite a dirty industry. It's great for moving vehicles and goods around the planet, but 400,000 premature deaths a year attributed with high sulfur output. We know the maritime industry is trying to fix these, change into cleaner fuel sources, but what we also need to do is measure that impact, measure the data that's being produced from these mobile sensors. And actually, we can use that to do a global map of all of the congestion being pushed out by the maritime industry. And so when we talk about actually solving global issues, and especially global warming and climate change, being able to build these digital blueprints from a variety of data sources, automotive, maritime, smart city, mobile, the ability to measure our planet is the first step towards optimizing and fixing these issues. Thank you very much.